Hello, everyone. Welcome to the Super Bowl edition of Space Talks with the UChicago Space Network. My name is Josh Levitt. I'm an alumnus of the college, and I am also a Major Gifts Associate Director for the Physical Sciences Division, which includes all things astrophysics and aerospace. And I am delighted to welcome you to hear from Matt Shieh, the co-founder of Canopy Aerospace, introducing the next generation of spaceflight safety, among other things. We'll hand things over, set the stage for us to the leaders of the Chicago Space Network, two of our prominent board members, first Dave Fischer, and then Gaurav Kumar. Dave, over to you.
Hey, Josh, thank you. Good morning. I like that Super Bowl Sunday. We did schedule this at a good time so that not only do you see the Super Bowl, but directly following this talk is Puppy Bowl, which is sort of a highlight at our house on Super Bowl Sunday when the Bears aren't playing. Welcome to the February Space Talk. I would like to welcome the members of the Booth Space Club, which is another space organization on campus that we're co-sponsoring events with. I know a lot of them are attending today. This is a monthly event, and we certainly welcome you to check it out, get involved. If you'd like to get more deeply involved with the University of Chicago Space Network, please feel free to reach out to me, Gaurav, Josh, any of us on the board. I'll keep it short, and with that, I'll turn it over to Gaurav.
Thanks, Josh and Dave, and good morning, good afternoon, everyone. As was mentioned, we continue with holding our space talks on unique dates. The last one was when Orion dashed back on, back to Earth. I hope we will continue the tradition. We are very grateful to Matt to join us today and be willing to share his wisdom and experience with us. Matt is a CEO and co-founder of Canopy Aerospace. He has spent 8 years in U.S. Air Force as a B-52H weapons systems officer with over 1,000 flight hours, including 250 in combat. He has also worked on developing operational and strategic plans for NATO partners, and he has a bachelor's in international studies from University of Kentucky and an MBA from Chicago Booth. Welcome, Matt, and thanks a lot for taking time.
Yeah, thank you, Gaurav, and the rest of the community for having me. Looking forward to sharing my story here with everyone.
Perfect. So, Matt, the way we hold these talks is that we start with your background. We go into the work which you do. And then we also, towards the end, we focus on how the UChicago experience has shaped your personal and professional life, and what other guidance and advice you will have for the university community. There will also be Q&A throughout the session, and if in the audience someone wants to ask the question, they can also unmute themselves and ask the question during our talk. So to kick us off, Matt, would you please give us a brief background about your personal and professional journey and your passion for entrepreneurship and aerospace industry?
Got it. Yeah. So background of myself. So I'm originally from a town in Kentucky called Lexington. Ended up growing up here for the last half of my academic career. Went to the University of Kentucky. I think like many college kids, I didn't really know exactly what I wanted to do yet. Was still trying to figure that out, and still needed quite a bit of guidance. But my childhood goal was to be an astronaut, but I think 9 times out of 10, a lot of kids have that goal as well. That clearly didn't turn out how it was supposed to, but I actually wanted to be in the FBI kind of in college, and I knew that on their website there were certain criteria. You had to be an FBI agent, and you have to have some good experience initially to go in, and I clearly didn't have the grades for it, and didn't have that experience yet. So I looked at going into the military. looked at a number of different branches, settled on the Air Force, joined the ROTC program in Kentucky, and then graduated, commissioned as an officer there. Went down to Pensacola, Florida, where I did flight training for 2 years as what's known as a combat systems officer. So that's basically the people on board during flight that are the mission commanders, and they manage, operate, employ weapon systems, electronic warfare, and overall navigation systems. Completed training there, and then went on to my weapon system platform, which was the B-52. So went in as a role as a weapon systems officer. So that is strictly operating, employing conventional weapons, from GPS, laser guided munitions to cruise missiles, and then also nuclear capable cruise missiles as well. Spent about 5 years in that community, few deployments, went over to Guam, Southeast Asia, and flew nuclear deterrence missions out there, and then spent some time in the Middle East, operating out of Qatar, flying missions during Operation Inherent Resolve, which is during the whole ISIS, eliminating those from Iraq and Syria. So did that for the first 5 years, flying around the world, and then decided to take a break from flying, went to Europe, applied as a air liaison officer out there. And that's taking my tactical and operational skills and advising US and NATO forces out there on how to employ US Air Force assets and kinetic capabilities. Also spent some time leading our Air Force special operations teams out there as well. So if you've seen like most movies, they're basically the guys that attach to Army units and others that call in airstrikes called TACP and JTACs out there. Did that for about 3 years, and then was now looking at, the military taught me a lot of structure, leadership, teamwork abilities, and I was looking for kind of a new opportunity and challenge. And part of me had gone back to, well, let's go back to the childhood dream of going into the FBI. So I'd actually applied, went through the year-long process, got selected, got a conditional offer, passed all the testing, and then ended up not passing one of the other tests we had later on in the application cycle. So that career pretty much wrapped up pretty quickly. And then I was looking at, well, okay, maybe the government isn't going to work out for me anymore. I should kind of focus on the private commercial sector. I've always been pretty inspired by my family, come from a long lineage of entrepreneurs and founders, from my dad to all my aunts, uncles. They've ran kind of international trade firms or had their own kind of businesses, buying and selling goods. And then my cousin as well, he's a startup SaaS founder, is raising his Series A right now. So been kind of surrounded by that for the last few years and growing up. So then I looked at business school, applying to business school, did kind of a late application cycle, applied round 3 to all the business schools, and then luckily ended up here at Booth. And then that's where it's kicked off my entrepreneur journey. So graduated from Booth in June 2022 last year. And then that's where I had started Canopy.
Great. Thanks a lot, Matt. That's really interesting. And, a lot of the audience or the listeners who are in their college or university would be going through similar pathways, as you said. And can you maybe talk a bit about how did you, like the FBI process, the selection process you went through, and at the end, for some reason, you did not get through, and then you tried something else. Can you talk through how did you feel at those moments, and what drove you to take these different routes and plan for your career?
Yeah, I'd say, at that moment, that was kind of a lifelong dream, but, figured out that wasn't going to happen anymore. But that always connected with, right, my own kind of personal mission and drive. And that had evolved right in the military to where, we're doing things on an international level and, really making an impact on, different areas and countries, and, working alongside allies and partners out there. I kind of went back to, what is it at my core that I care about. Going through business school, right? Getting out of the military was I was pretty siloed within, right? What do I know? And it's all about Air Force and other branches and what we do. But seeing all the opportunities out there was almost overwhelming to me. And it's just great. There's a lot of opportunities, right, in the private sector, but part of it was still a lot of it was still very mission oriented, right? Figuring out, well, what's like kind of like my next calling and the next mission, and that became space and aerospace, right? And the overall defense industrial base and industry is what it's evolved into, right? Being part of a higher level mission in space now is, right, enabling what's called the low Earth economy out there, because anything that we develop in space is what enables better things here on Earth, and that's where how I found alignment with going from military mission needs to backing out and aligning a lot of what we're doing now with kind of higher level space and just improving overall humanity on Earth.
Thanks, Matt. Yeah, that's that's very critical, and I think JFK had said that the one who wins in the space will win on the Earth as well. So there's a clear link, as you mentioned. And then switching topics to Canopy, can you talk about how did you come up with the idea, and how did you establish the business which you have today?
Yeah, so knowing that I wanted to work within the aerospace and space industry, I started looking at, well, what are the best ways to kind of get in contact and get in contact with the people in that field and expand my network. So came across a program called FedTech out of DC from a few friends I had in my network that had gone through that program as well. And what FedTech is, they're basically a firm that connects 3-4 letter agencies, university labs and research labs, technologies from those areas with people on the commercial side to look at developing a business case, commercializing certain technology for the rest of the industry. So from there was connected with the NASA Ames Research Center out of Moffett Field, California. And this is the division that's been developing heat shields for the last 7 decades. And in speaking to people there, became apparent that this was a good lineage to a lot of the things I did in the military. They've been developing heat shields and high temperature thermal protection for things like ICBM programs, missile systems, to the space shuttle program, reentry capsules, and now reusable rockets, orbital spacecraft, and hypersonic systems. So from there, learned very quickly that the overall supply chain for thermal protection was a critical need for the industry, but was also severely bottlenecked. A lot of that talent had either went on to other industries or had kind of retired after the space shuttle era, and there wasn't really good manufacturing supply chain. So ended up speaking to dozens of space companies during that journey and really found that, okay, well, there's a critical need for developing a better manufacturing process around these materials, and that this could actually enable the future space economy and future logistics and rocket systems that are in need of it today.
Thanks, man. And can you talk about the supply chain which exists today for the TPS, and how does Canopy make it better, or or increases the value in that supply chain?
Yeah. Well, first, let me describe TPS a little bit as well, because I think people may not be familiar with that acronym. So TPS is defined as thermal protection systems, or the other word for that are heat shields. So anything that is re-entering the atmosphere is going at Mach 25 or faster, 25 times the speed of sound. or anything that is going hypersonic speeds over Mach 5 within the atmosphere needs thermal protection. When you're going at speeds that high, temperatures start getting up to the 2,000, 3,000 degree range. And, current metals today are, too heavy and they'll lose structural integrity as well once you get to temperatures that high. So we use what is a low density, highly porous ceramic material out of NASA, and it's basically a class of materials. But thermal protection as a whole, what we're doing with that, a lot of it's still legacy manufacturing, right? You're using injection molding, casting, it's not automated. In ceramics, it's still very kind of a artisanal process is what we call it, because it's not automated. You don't have like a good streamlined process for it. And so if you're looking at, right, today, we need to transition a lot of our manufacturing processes to Industry 4.0, which is digitizing the manufacturing process, making sure that we have the data exchange and connectability. I don't think that's a word, but we'll go with that. And making sure that all these things talk to each other. And so when we're looking at the current process and how it's done today, well, it's costly. It costs up to $10,000 to make, right, little 6x6 inch thermal tile. You don't have design for manufacturability around it. There's no generative design as well. And it's still very, everything is kind of siloed. And so we're working on introducing 3D printing, additive manufacturing into the process. So converting existing formulas today, and then also using a automated robotic system to do a lot of the thermal spray coating on the back end as well. And then when I talk about design for manufacturability, we're building more of a manufacturing platform where we can actually have design parameters in place, and we can ensure that, well, the design specifications that we get from engineers can actually be manufactured as well with our current machines and systems, and we can 3D print them. And then also introducing generative AI design for engineering as well. I think down the road, we'll want to be able to quickly enhance current parts and components today, and you can do that with generative design, much like you have Chat GPT, right? If we're helping, it's a big topic of AI last month, but a lot of engineering today, you can use those to enhance, right, what you actually want to produce, but you have to have the set parameters in it as well. You need to make sure, okay, well, if it's gonna enhance the product through AI, you need to make sure, okay, well, it still has the same structural integrity, it doesn't cost 10 times more to make, and that it can actually still support the current system that it's integrating into. And so you need all these processes and systems together to be able to evolve into the next standard of industrial manufacturing, is having a more integrated manufacturing process and supply chain.
Thanks, Matt. And two more questions on that. In your, when you were speaking with all these different space companies and also NASA and Ames Research Center who have done, heat shields for 70 years and have a lot of experience, what were the kind of challenges you were facing in understanding the needs and the problems which they had, and their receptiveness towards the solutions to change and make them better?
Yeah, I think the difficulties were, a lot of the know-how and knowledge is within NASA, and it's something that is not really public facing right now. So we had to develop what's called a Space Act agreement to basically allow us that tech transfer to be able to transition these processes out. But I think the most challenging part from a technical perspective is that heat shields, right, depend a lot on the environment that they're going to operate in. And what we want to do is drive standardization in the industry, which a lot of times today, right, every company is vertically integrating. They're doing their own manufacturing process, their own type of heat shields, which may be made of similar materials, but they may not be qualified. they all have different reentry profiles, different speeds, different aerodynamics, and different fluid dynamics around that, and heat profiles. So it's not as easy as making, like, stamping a standard component in an aircraft and saying, okay, this goes on like every single aircraft, and that's kind of like the standard. Heat shields are still, it's a very tricky part of the industry where it just depends on the vehicle and a lot of other variables and parameters. So it's ensuring that as we transition this to a better manufacturing process, but where manufacturing can also still be used within other use cases as well, and be pretty dynamic as well.
Yeah, and you have, I was reading some of your other interviews, and you have also spoken about modularity, which you touched upon briefly. Do you, how far do you think we are in the space industry with respect to modularity? Will it get, disintegrated, the value chain, eventually 5-7 years from now, or you think it will continue to be, especially with respect to TPS, it will continue to be very specific?
Yeah, that's a good question. I think we're still probably a decade away. I mean, if you look at how the aerospace industry evolved, I think at one point in time we had over 150 airlines back in the 50s, 60s, and that all had to be consolidated, right? Everyone was vertically integrated, developing their own supply chain, making their own parts, and that's what you're seeing a lot with the space industry today. And that's a natural evolution, right? Because you just didn't have the supply chain for it. And that's the same thing today. We don't have the supply chain for thermal protection and heat shields. And so we have to evolve into more horizontal integration. And as part of that, you have to drive standardization. And standardization is still difficult as well. But as long as what's known today is that companies and space companies are going with existing technology that's traditionally been flight qualified, has flight heritage, has flown on NASA shuttle programs and missions, and are using those today. What we're interested in also working on is the next generation of heat shields and material science on better performing ceramics with a good manufacturing process as well, because it doesn't help to improve the material science part if it still costs you $10,000-$20,000 for a small part. You have to improve the overall manufacturing process, and you have to make it better. So we're marrying that part of the process along with, well, we'll continue to do R&D and improvements on the material science part, and convert that to a better manufacturing process, which is through additive and through 3D printing as well.
Yeah, and Matt, you do have a manufacturing site. Can you talk about, how did you go about, building selecting the manufacturing location and the manufacturing process, and the thought process for you as an entrepreneur getting into a hardware business? What was the thinking there, and what were the challenges in that part?
Yeah, so the site, we are finalizing the contract actually right now. It's a long process, but we are planning to be in South Denver area. Found a good facility there, but in first of all selecting a site, you have to make sure that there's room for growth as well. So we don't want to move into an area, a facility, and then be there for a year and then we have to move out or kind of expand facilities. You have to have the right power as well, because we're using very high temperature furnaces and industrial equipment that requires a lot of power. And then you also have to make sure that you have the right kind of facilities built in place as well, like the right venting systems, all that. But getting a facility as a startup is a lot more difficult than being a more well-established company. So we've been working on this deal, this commercial deal, to get a place, a facility, for the last about 2.5-3 months, because landlords look at our company as a risk, because we we don't have enough runway for the next 2 years. We don't have revenue. We're not an established entity. So there's a lot of risk for them. But I'd say finding a really good broker helps a lot. And we have a really good one that's been fighting for us. And we're finally about to get into a facility next month. And then we have all of our equipment on order as well. And it's standing by to be shipped. And that'll allow us to develop our first manufacturing process, which we are bringing on the legacy systems and manufacturing processes initially. And then we're integrating additive processes into it. And we'll be up and running by Q2 of this year.
Wow, that's exciting. And Matt, the other challenge, in setting up your business is finding the right partners and finding the right talent.
Yeah.
Can you talk about that, and what do you look for example, when you are, if someone is interested in joining Canopy, what should they focus on? What are the things which you look for in a new hire?
Yeah, no, it's a good question. And as far as, I'll backtrack a little bit to the location, right? We chose Denver because of the aerospace industry there. You have all your defense primes there, a huge space startup networking scene there, as well as some of our investors are there as well. And then just overall from a personal side, it's a good area to kind of put some roots down. But as far as what we look for in hiring, my standard is, we're not looking for necessarily the best person for the job, but we're looking for the right person. And what that means is you need someone that understands, has the risk tolerance to be in a startup, can be dynamic, can wear multiple hats, can operate and get things done no matter what the job or task is, but also has the potential and know-how to figure out how to get things done, right? You may not be, the person that knows how to, maybe make like a better heat shield material, but if you know the right people to talk to and know how to build that plan, then that's just as good as someone that knows how to do it themselves. But for us, it's the first 10 people on the team. What really matters is the culture and how well we work together, because we all have to be working as one team, swimming in the right direction, and working towards one mission and one goal, and it's being aligned with one another. But yeah, we've a lot of the core part of the team, and we have a lot of fractional members as well. They come from the booth community. We have one part-time software developer. He graduated from UChicago Computer Science last year, and he was an intern that helped out with some initial software development. And now he's just working with us part-time, aside from his full-time job right now. But it's, we're leveraging kind of the internal network right now, but making sure that they're mission aligned, culture aligned, is the first criteria for us. And then once we expand bigger, then the culture and the company defines itself, and then we can bring in other people and make sure that they match at least who we are as a company and our identity.
Yeah, and Matt, can you? That's great. Thanks for that. And going back a bit to to Canopy and its establishment, your vision is to lower the launch costs, reduce the lead times, and increase the safety. Can you talk a bit about the costs in the TPS industry, and where do they stand today? How have they, moved over the last 30 years, and where do you see it going, and how do you think you would be able to bring the costs down?
Yeah, well, costs haven't changed a whole lot over the last 30 years. The manufacturing process, as I mentioned, was still casting, injection molding. You're doing a lot of manual kind of spray processes on the thermal coating afterwards as well. But in order to improve that, one of the natural manufacturing processes today is additive manufacturing. And the reason why heat shields today are so expensive. Part of that is because when you make the heat shield, on the back end, you use subtractive manufacturing, and that's using CNC machining and tooling, and you're shaving off a lot of raw material. That this is expensive kind of raw material input, and that's hundreds of thousands of dollars you're wasting on the back end. And so, I mean, that's a a standard or a trait that's common just within manufacturing in general. But for us, you can lower the cost immediately by transitioning it to an additive formulation and building it from the ground up. Um, that plus having a more automated system, right? The robotic autonomous processes will allow us to develop a lower the overall lead times, right? Increase the cycle times as well and throughput, which overall translate to lower manufacturing costs as well. Some other things we're doing for advancing the current state of the art is also sensor integration. So we're integrating wireless sensors into the company, or not the company, the material itself. So we're taking high temperature ceramic sensors with a partner we're working with right now and transitioning our materials to what are known as smart composites. And that will allow us to actually monitor for structural integrity, monitor for temperature, pre-flight, during flight, and post-flight, and actually increase overall safety of flight for aerospace and space systems as well. If you're looking at the, we just had the 20-year anniversary of the Columbia Space Shuttle disaster, and the main fault in that was, well, the thermal protection system, the heat shield, had failed on that spacecraft, and they hadn't detected it because we didn't have the right sensor systems in place, and that led to a critical failure when they re-entered. So if you're looking at future modalities of travel, right, we went as a society from traveling by sea and with like sailboats and ships, right? What are like the critical technologies that enable that? You had like the sextant for navigation, you had the steam engine, railroads, and then fast forward into like jet engines and rockets now. But the next step in that is towards hypersonics, right? How do you get somewhere faster? Well, we got to go faster. We know how to do that. We just have more powerful engines and make sure they can work at altitude as well. But then the material science part as well. You have to have better material science, and you have to have better heat shields, because if you're going too fast, well, your aircraft or your missile system will just fall apart. So improving the material science part as well. But yeah, going back to the manufacturing process, it's all, a lot of it's about automation. The raw material input doesn't really change, but it's how you manufacture it is how you can reduce the cost there.
Thanks, Matt. Yeah, I remember from my aerospace undergrad that one of our aerodynamics professor would always say that you can fly anything with a strong propulsion, but you need to ensure that you are efficient in using your fuel, and that it comes back safe. That's why structures and aerodynamics are very critical to
Exactly.
And Matt, another question on your when you founded, how did you, because your co-founder is a material science background person, can you talk about how did you meet, how did you go about finding the right partner?
Yeah, so he actually came from the FedTech community. He was a mentor for the team. That's how I met him. And as we're speaking more about commercialization and advancing the material science part, it became apparent that, well, his background, it was, I think, kind of just by chance, really, but he's PhD in material science, John Howard, and his background, he's got another company that he spun up a few years ago that advances overall the advances glass foam composite type materials for Navy systems, which is very similar to the ceramic materials we're using today. So he understands the manufacturing processes quite well, the material science part. And this is where I talked about, right? Like he didn't have direct experience making heat shields. It doesn't matter. But he has the ambition and the know-how of, okay, I don't know how to do it exactly, but I know how to talk to the right people and figure this out and build out basically a plan for it. And also a great business partner, and just overall great guy to work with and build out this company. And that's what I was looking for was people that were also very mission aligned, and he was very aligned with let's push the state of the art of materials for hypersonics, for space, and then enable the future economy through a better industrial supply chain for it.
Yeah. And one more question, Matt, on the business. Who do you think is your competition? How do you think about competition at this stage and going forward?
Yeah, for competition, it depends on a lot about the markets we plan to open up. And it's something we haven't spoken too much about, which I'll get to in a minute. But immediate competition for us on heat shields are a lot of your vertically integrated companies that make their own right now, who are looking at, okay, well, maybe it's time to outsource this or just partner with someone. There's always going to be kind of some internal competition there. And then there are some kind of legacy pre-existing companies out there, like Spirit Aero. They've made some acquisitions that make heat shields for hypersonics, and then also some kind of legacy mom and pop shops that make it. But we're focused a lot on manufacturing process improvement and developing reusable heat shields, also ablative ones as well, that can enable certain critical systems that we've assessed will build out the future space economy. And those verticals include things like in-space manufacturing, for example, which is basically using microgravity to make things in space, like better pharmaceuticals, better fiber optics, and other systems as well. You need to have the logistics built out for that, which is hundreds, if not thousands, of re-entry capsules in the future. Bring those back, and if you're sending anything back down to space, you have to have the right heat shield for it. And then also orbital spacecraft. There's now new companies that are developing spacecraft that are similar in size to a space shuttle. And if they're going to re-enter, they also need the same kind of heat shield material that NASA built, and that doesn't exist commercially. So yeah, competition, we have a lot of legacy players as well. But for us, we've opened up potential companies that we will compete with as well, because we're actually expanding our overall market model as well, to where we are zooming out our capability as a company, where we have gone layers and layers deep on developing better manufacturing for thermal protection and heat shields with a better digital manufacturing platform and process. But also, as we were going through that process, we also figured out that, well, every other industry within ceramics has the same kind of process and same kind of problem as well. So now, while we were building a solution for a very niche part of the industry, it's actually a very dynamic and industry agnostic solution for any other kind of manufacturing process within ceramics as well. So, we're in parallel developing additive and 3D printing manufacturing processes that allow us to actually make components, high precision, high temperature components for other industries like semiconductors, the biomedical industry, general aerospace and space, satellite systems, and then as well as automotives as well. And what we want to enable is mass customization of high precision ceramics, which doesn't exist today. That industrial supply chain doesn't exist for additive. It exists for legacy, your traditional manufacturing processes. But if you want to get to very complex geometric shapes, have rapid iteration, and then also want to save on costs as well, then a lot of the industry is transitioning to additive manufacturing as well.
Got it. And switching gears now to UChicago and your Chicago booth experience, can you talk about how Chicago booth and UChicago overall has helped you in shaping your career and building up the company?
Yeah, sure. So I didn't have a business undergrad background, and I think the first time I looked at a spreadsheet was probably in business school. So getting into a good business school was important for me to build out the foundational, right, background and know-how of how business works, right, which all is pretty straightforward once you understand kind of like the financial part of it, all the financial statements. But what's critical and important is, well, how do you build a company that's venture scalable, that has products and advancements that can allow you to get to that stage? And what was great about Chicago booth and going through that program was surrounded by great professors that have done this before in their own startups and companies, and taught us, okay, well, how do you work backwards, right? If you want to, right, one of the big things I always discuss and talk about is, well, what's your exit strategy, right? Is this a lifestyle business? Do I want to make heat shields for the next 30 years of my life? Probably not. Or is this more of a 7 to 10 year plan, right? How do you want to exit as a company? Do you want to IPO? Do you want to get acquired, right? And then you start working backwards with that. It's like, well, what kind of technology are you developing? And for us, right, there's nothing extremely unique or special about tech IP and transfer. Anyone can do that, right? Anyone can go pick up the phone and call an asset and say, hey, I'm interested in technology, I want to transfer it out. But it's about how you package that up. It's about how you develop IP around it that makes you unique and makes you potentially venture scalable. And the IP that we're developing, I learned that through a lot of booth classes, right? On just like product development and, right, how do you make something that is more of a horizontal integration across the entire industry that can allow you to have, right, a smaller market size where we assess TPS to be about $3 billion over the next decade, to, okay, well, we're developing enabling platform technology for a $300 billion ceramic market in the next decade. The booth taught me a lot about, well, how do you think dynamically and think about, right, here's like your current silo, but how do you zoom out as a company and build something that's for the rest of the industry as well? And having access to things like New Venture Challenge as well was, I think, extremely important because, not only was I surrounded by really, really smart classmates that are way smarter than me to help start this company, but also allowed us to test out our ideas through New Venture Challenge, which that is Chicago Booth's basically startup accelerator. Allowed us to pitch in front of real VCs, work on our pitch deck, get asked the hard questions, and really figure out, okay, is this an actual company that's viable, or is this more of a business school project that's not going to go anywhere? And so every investor I always speak to, I always ask for feedback, right? If they say no, I say no to giving investment. I always ask, well, why? Can you provide some feedback? And so all those questions I take, that they help shape me as an entrepreneur, as a founder, and they help shape the overall business plan. It's constantly evolving every single day. So always being open to feedback and being able to shift and work in a very ambiguous environment. I think that kind of stemmed a lot from the military as well. We would oftentimes we put environments where we've never encountered before, but you go back to like the foundational structure, the training, right? And you get comfortable with doing things that you don't know how to do, right? Comfortable being uncomfortable. And Booth provided a lot of that framework as well. But then it enabled the overall environment for me to actually test out a lot of things before going into the real world, kind of environment after graduation. And then surprisingly, we did well in MVC. We got third place, which was about $200,000 or so in investment, which, fundraising is traditionally very hard for a deep tech or hardware company. And by layering in software as well, and now you start looking at, okay, well, what does the exit look like for a software hardware company? What are exit multiples? What do investors care about, right? And it's making their LPs money, but then also doing things that are interesting and enabling for not only this one field, but also a number of different other fields as well. But yeah, I owe a lot of probably everything about starting a company to having a good network and education as well. And I got that through the Booth Network.
Thanks, Matt. And what, you mentioned some of the challenging experiences during your Air Force days. Can you talk about, if you can, talk about maybe one of the most challenging ones and what it was, what did you learn, which can be translated by others as well on this call in their own lives?
Yeah, I think I'll go back kind of to the training aspect of it. When I deployed to Qatar and we were flying missions out of there, our whole entire unit, the B-52 community had not seen combat in over a decade. So the only people that knew like what they were actually doing had seen it a decade ago, and those were our senior leaders and commanders. But as a community, we didn't really know what we were doing. We knew what we were doing. We've been trained, right? We train on bombing ranges back home. We train on simulators, but the real thing is always different, right? But what do you do when things are different or they're not going as planned? You always go back to your training. And you go back to what you learned. And going from kind of a training simulated environment to a combat environment was something that I saw a lot in going to Booth is kind of like the simulation training environment, learning the foundational skills, right? Testing these theories out with, potential VCs was something that was very similar to military training. Well, I'm testing all these theories out. And we want to build the reps, right? The muscle memory. Or okay, if something goes wrong, I don't just freak out and kind of do whatever. I go back to the training. I go back to the foundational skills. And I think being in the military, that taught me a lot about, right? Focus on the easy, the simple, like foundational skills, right? For me, it's getting really good in finance, getting really good at commercialization, what makes something scalable and what allows me to repeat that process in other industries. And I think just having the opportunity to be in a very ambiguous environment where we'd be flying into territories that we've never seen before, and we didn't know what kind of threats were on the ground, what kind of missile systems were there exactly, what kind of targets, what kind of enemies and things we would have to eliminate. But you learn as you go, but then you also make sure you have enough risk tolerance as well to actually take some risk and actually be successful with those, but also have a good risk profile as well. And if you're an entrepreneur, then you're definitely very risk tolerant. And I think that's one of the traits that I think military translating to business taught me a lot was risk profile, was ambiguous environments, and then going back to structure and training and building out those foundational skills. I spent almost 3 years training on active duty, getting good at skills before we were operationally qualified. That's a long time. That's almost like getting another degree. But that pays out dividends in the future for, right, whether it was in that community dropping bombs or outside in this community on the private commercial sector, right? What do you focus on? You focus on the basics and the training, and that's what gets you to I think survive and where we are today.
Thanks, Matt. A lot of great advice in there. Really appreciate it. And I don't see any questions from the audience, but anyone in the audience, okay, Travis, please go on, unmute yourself and ask your question.
Thank you, Gaurav, and thank you, Matt, for talking to us today. I actually, John Howard and I go back to University of Maryland. We were both going our PhD there at the same time, so it's great to hear his name and hear a little bit more about what he does. My question for you is going back to, you were talking, you spoke a little bit about how your technology with ceramics will be able to be applied outside of space, but obviously space is your main focus right now. Yep. So how do you balance seeking opportunities and funding within the space industry versus trying to almost with diluting yourself too much by trying to reach out to other industries?
Yeah, no, it's a really good question. What we want to do with the material science part on the ceramics, it's not necessarily taking space grade material out and then displacing current use cases and materials. Let's say we're not trying to take a heat shield ceramic and displace current brake systems in today that use ceramics. It's developing more of the platform for it that allows us to have an additive manufacturing capability, which doesn't exist today. So that's kind of, we zoom out a bit on not the material science, but the manufacturing part. But as far as dilution goes, the way I've described it, and we are raising additional capital. So to answer your question directly, we only raise capital for the TPS part. But we've noticed, well, we can actually really open up the market, de-risk our customer base, and actually develop this into a much larger company by opening up the market now. This has always been a second, third phase of the company, but this is where I mentioned speaking to customers, understanding the demand and need, and I think timing is critical. If you don't, time yourself right, and if you don't act fast and quickly, then someone else is going to see the opportunity, and someone else is going to take it from you. It's a question I struggle with every day. Is does this dilute our current narrative? Does this dilute, our current capital, and can we still get to both at the same time? I think the answer is yes, always, if you have more capital, which I'm raising right now, but then also not necessarily putting everything on capital requirements is right, getting to revenue faster, which we're working on by Q2, but building something that's repeatable and that has a lower barrier of entry. And for us, it's developing a more agnostic platform and company so that we can continue to support other industries with a capability that's needed, but then also continue to use that cash flow from those operations to support critical areas like thermal protection for hypersonics as well. But the narrative is important, but you have to balance that right. And for us, it was ceramics is a good lineage, right, with TPS to every other industry. And we're developing a better manufacturing process for TPS. And that translates into, well, this is an agnostic platform and better manufacturing process for any industry. So let's start to open it up. But does that answer your question exactly?
Yes, it does. Thank you, Matt. Appreciate it.
Yeah. Thanks for joining.
Any other questions in the audience?
I have one.
Go ahead, Josh.
Yeah, Matt, I read in another piece, you used the analogy of thinking of Canopy Aerospace's work like Rolls-Royce selling and maintaining engines for Boeing.
Yeah.
I was wondering, could you elaborate on that analogy?
Yeah. What does that mean exactly? Yeah. So this is where you fast forward in the future, and let's say every rocket or space vehicle has our heat shield on it. How do you maintain it, right? Not everyone wants to maintain their own heat shields. Same for engines, right? Not everyone wants to maintain their own engines. So that's where we enter. Okay, from a business perspective, how do you survive as a company, and how do you generate cash flow and revenue? So that's the MRO, maintenance, repair, overhaul model of okay, we can sell material to someone, we can sell a good heat shield, but they're not going to know how to maintain it exactly. They don't even know how to make it. But we can go in after a flight, resurface it, requalify it, repair it, and then continue to maintain that that engagement and partnership over a lifetime value, instead of just selling products. Right, it's a one-off revenue stream. This converts our revenue to recurring revenue and cash flow, where that's what they do with a lot of engines in the aerospace industry. Is you sell the engines, and then you do MRO on it, and that's how a lot of other components work. And that's the same thing we see for the space industry and critical path components like heat shields, where the human capital and talent to make it is almost non-existent. So where they would just want us to maintain and make the problem go away, right? It's like, okay, this is your expertise, this is your domain, you guys deal with it, right? Here's a 10-year contract. That's the ideal scenario once we get to scale, but it's still early on. Space industry is still developing. Yeah, MRO also translates well from our sensor integration part, where we want to integrate sensors into materials, which we're testing right now, and that can lead to better predictive maintenance, right? You can get a lot of data capture from that. And right, when you're flying a plane, like when we were flying the B-52, a lot of that data capture is manual. You capture airspeed, elevation, altitude, what are the variables involved there, and you send all that data back to Boeing, and then they take that and they put it in the spreadsheet, and they figure out like, okay, well, we'll have to do maintenance on either this part or the airframe over time. But this is where we need to get to Industry 4.0, and then have a more integrated material system that talks with the rest of the manufacturing process and on the operational side as well.
Yeah, thanks. I appreciate it.
Yeah.
Thanks a lot, Matt. Really appreciate your time. Before we close, you have mentioned that you really love sci-fi movies. So which one is your favorite, and do you have any book recommendations for the audience?
Yeah, on the movie part, yeah, naturally, as a military veteran coming out and doing a space company, it would be Starship Troopers. That's been the movie. Yeah, it's the classic. I mean, the book is great as well, but I know probably every line from that movie, and can recite it. But yeah, it's been one of my favorite movies for a long time, and I can still sit down and watch it all the way through. On the book part, I recently read a series of books called We Are Bob, and it's basically a trilogy of books called Bob is like basically the spaceship system with this guy's consciousness that got uploaded into it, because he signed a deal and a contract to have his brain like preserved after he died, and another corporation bought him, and they put him in like a space exploration vehicle. So now he's traveling the universe, and he has a 3D printing capability, and he basically replicates himself across the universe into other exploration vehicles, and they go explore the universe. That's why, and his name is Bob, so it's called We Are Bob, because it's like an entire star fleet of Bobs that just travel the universe, which is a very funny, interesting book. I would recommend the audiobook version if you're gonna listen to it. Yeah, those are the recent sci-fi movies and books I'm interested in.
Thanks a lot, Matt. Really grateful for your time. And Josh, over to you to close.
Yes, I know Dave needs to get to the Puppy Bowl, which is starting now. So I just want to thank everyone for joining us this afternoon. It's always a pleasure to hear from the UChicago Space Network. This is a especially talented community of Maroons who are professionally and intellectually invested in outer space. I want to thank the UChicago Alumni Engagement Team for providing this Zoom room for us to convene in. I want to thank Dave Fischer again for his Space Network leadership. I want to thank Gaurav Kumar for his leadership as well, particularly in leading these Space Talk conversations. And I want to thank Matt Shieh again for sharing his career journey, as well as his vision for thermal protection systems. Keep an eye on your inbox for the recording of this conversation. Plus news about our next space talk. In March, we'll hear from UChicago physics scholar Abigail Virag about neutrino astrophysics, relic light from the early moments of the universe, and what it's like to perform research along the ice sheets of Greenland. So feel free to reach out to us anytime. I dropped our contact information into the chat, and we hope to see you next time.
All right, awesome. Thanks, Josh. Thanks everyone for having me.
Thank you.
Hey, Jimmy. Yeah, Karen.